to one more episode of Drug Discovery with Cure. I have with me Avinash Kumar. Avinash has done his bachelor's, master's, PhD in related areas of biotechnology. His PhD work was phenomenal work on caffeine, and he has been working with us on antioxidants for SARS-CoV-2. He is in fact heading a group with us, but he can be very useful for another thing, which is essentially metabolic biochemical engineering in plants, so that whatever our supplements, let's say if we find some plant to have better effect in dealing with SARS-CoV-2, how can we increase the yield of the active ingredient if the synthesis is slower? So in an ideal situation, you want to synthesize the molecule, but in several cases, you may want to simply enhance the yield of secondary metabolite from plants, which is acting as a medicine. So that's where Avinash becomes very important for us. Welcome to the show, Avinash.
Thank you, Dr. Satan. Thank you for the introduction.
Avinash, can you tell me a little bit about your PhD work before? Can you tell me what you did for your PhD? What was your research about?
In PhD, I actually looked out for molecular regulation of caffeine biosynthesis in coffee. And so we had these two approaches. First is to delineating the promoter regions by transient expressions of GFP. And the second approach was to characterize the transcription factors which have a binding domain or binding motif on the promoter. And the third approach was to create a knockdown of caffeine in planta, that is in coffee plants. So regarding the transgenic knockdown, we used RNA-directed DNA methylation technology, and this was because caffeine is regulated by many genes, and there are multiple genes for each pathway, and so it is not very easy to block one gene and not block the other gene also, because they have a good amount of similarity. Many of them are 85% similar. So we targeted the promoter regions, and we developed a transgenic knockdown coffee, which had approximately 30% lower caffeine by targeting the second last gene of the pathway, promoter gene of the pathway, which is called sodium synthase.
That's wonderful. That sounds exciting work. And caffeine is obviously very interesting. And you know, I think this whole idea of metabolic engineering has a lot of promise. So how can you go about doing metabolic engineering in plants to increase yield of active ingredient in things which are being used for supplements?
Well, there are two major constraints when we think about doing a metabolic engineering. First constraint comes from the plant stage, whether we are taking the whole plant or a part of the plant, or we are going to the organelle context. So this is the first constraint. And the second constraint is the steady state level of the metabolite. Steady state level depends not only on the enzymes, their activities, but also on other factors like what is the rate of the reaction, what is the allosteric control of the pathway. And so when we look at the second part, that is how to target a particular metabolic pathway to get a metabolite at higher yield than what we can anticipate. There are recent computational methods called metabolic modeling and metabolic modeling of pathways. And this computational method is based upon a linear programming method where steady state is defined as a state where the metabolite doesn't change in stoichiometric amount, and the dx by dt is equal to 0. And then when the constant is changed, an enzyme is added, a reaction is added, a substrate is added. So it can be linearly programmed with accuracy. So metabolic modeling is something very interesting and recently coming up.
Wonderful. So that's really great. Can you give me some examples where people have been doing sort of directed metabolic engineering.
Directed metabolic
Engineering, so where more the selection.
No, I didn't get your answer question.
So there are several plant varieties which have been selected. So instead of doing metabolic engineering, basically people have done selection, crop selection to get the desired results.
Okay.
What are the examples where people have done metabolic engineering and the results are out there?
So actually, this is a new area of research, and they work mainly on tomato, the carotenes. And the problem here is that most of the metabolites that are required to be produced in bulk are secondary metabolism. And unfortunately, secondary metabolism fluxes and secondary metabolic gene annotations are not very complete. And this is a hindrance right now in upscaling or downscaling. However, as an example, there are examples from tomato, the carotenoids, which have been attempted on this method.
Mm-hmm. Okay, wonderful. So, Avinash, it was very nice talking to you. I know the tomato example, people have even been engineering some interesting varieties, not just metabolites, so that people can grow them in New York apartments with very less size. So thanks a lot. It was a very enlightening session with you. I would encourage our audience to visit our website, ioncurerx.com, www.ioncurerx.com. We do extensive collaboration. We are working to fight SARS-CoV-2. We always put people first, profits later. In fact, for SARS-CoV-2 and for epilepsy-related drug discovery, we have no intention of making profits. We are working towards just serving humanity in those cases. Other diseases will be making minor profits. We don't work through, we are not going to ever be a publicly traded company. So we can afford to work on our principles. I hope you join our mission, and I hope you find our podcast useful for you. Thank you very much. Bye-bye.
Thank you.